Hi, I'm Tom and I talk about code. Welcome to another PlayStation 2 development stream where today we're doing housekeeping. Maybe not the most exciting, maybe not the most sexy, but after things went horribly wrong last stream, and for people who have not seen that video, I pulled at a thread, and that thread was transparent texture rendering. And as I pulled at that thread, my entire 2D renderer fell apart. I found a few odd, subtle issues in the Lua renderer, so we're going to jump in, we're going to investigate this renderer. I'm going to see if I can get this working in C and then port it across to Lua. I've got a little checklist, okay? There are 3 things I really want to look at. This is going to be a shorter stream. I want to look at alpha in textures. I want to clean up any warnings that come out of my compiler, and then I kind of want to tie this in, right? I want to do a cleanup of how I draw things in general, right? This code needs a review, it needs a passover, it needs some of its APIs maybe rethought. It's going to be interesting, okay? I'm going to get to talk about a lot of code and a lot of code ideas, and we're hopefully going to move reasonably fast, just like always. So git branch, git checkout, origin main. Let's quickly detour just before we get started on this and review our issues. I have quite a few. So this is what we're going to tackle today. Transparent texture's broken. We'll make a branch for this. But, you know, there's a few other things that I need to do. Like the naming path, I think we might start today. Oh, this is going to be fun. Yeah, so probably this and this are the issues that this ties into, right? When I say clean up, draw, that includes making sure that things have like nice logical names. So, let's jump in. Let's make... And you can see we do actually only have one warning, which is why my to-do was a singular, you know, fix warning. So we've got our texture test, and we can draw textured triangles now, right? So you can see we're drawing just a slice of this. We can rotate this triangle. We can do all kinds of things with this triangle that we cannot do with a normal axis-aligned sprite. And that's really cool. That's really good news. So let's jump in and let's see if we can make this transparent. So if I go script, example, texture, let's jump down to where we draw this sprite. We set the color, okay? So we have a red, we have a green, we have a blue, and we have an alpha. And all of these things are in the middle of the road. There's a bunch of interesting technical stuff about this. This is essentially alpha 1.0. This means, if you're savvy with hexadecimal, this means that you may realize this is alpha 2.0. What does it mean for alpha to be 2.0 versus 1.0? It's subtle. It's complicated, but the PlayStation 2 has this weird alpha range. Sorry, I'm clipping a little. I just need to turn myself. I'm just a little bit loud. I'm just a little bit excited. And I'll talk about that as the stream goes on. There's been some exciting things happening. So let's lower the alpha and let's run this code and see what happens. And we're going to see nothing, right? Nothing changes. Nothing is semi-transparent. Now, why is this? I'm not entirely sure. I wish I knew. By all accounts, this should work. It just doesn't. An interesting thing to check, before I go too crazy, let's make sure this is actually flowing through to the draw buffer, okay? So this is everyone's favorite thing, trace level. Let's have a look, let's get some trace logs, get some really meaty logs, and let's have a look at where these triangles are being drawn. If you've seen me do this before, then you know what you're in for here. If you haven't, you're in for a ride. We are setting a couple of registers. So each 4-bit nibble here is a register that we're setting in the GPU. We're setting 7 registers. We're doing it one time. That's just how this information gets packed together into one quad word. This is, you know, a GPU buffer command header. And the first thing we do, set register 1, that's the color register. So what do we have? We have red 80, that's what we set it to. We have green 80, that's what we set it to. We have blue 80, that's what we set it to. And we have alpha 02, that's what we set it to. So that is correct. This is flowing through the system correctly. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So that's good. We can manually unpack this information and verify that the correct data is being sent to the PlayStation 2 GPU. Perfect. So last time I went through the system hardware manuals and I uncovered that there is in fact an alpha register and we are never writing to it. What state is this alpha register in by default? I don't know. Is the default the same between the PlayStation 2 and the PlayStation 2 emulator, right? What are we doing with alpha? I have no idea. So let's find out. Let's find out by changing it. So let's go to draw Draw 2D.c. Sure. Let's go into where we're drawing. Let's go to the sprite. Okay, the sprite's a bit simpler than the textured triangle. We'll go into the sprite, we'll set the registers, this is all good. Set the primitive register, this is good. Before we set the primitive register here, we're going to add gift tag AD. We're going to use these AD register commands, and we are going to set the alpha register. It's just called alpha, okay? So this is going to take in our buffer, and we're going to tell it. Now this has, I need to get the documents up, I actually can't remember. Zathura, perfect, just on the page we left it. So we're going to set a register in the GPU, we're going to set these fields in it. Okay, so the PlayStation 2 is a fixed function rasterizer, right? That the GPU takes commands and it follows the same steps. That means there's no shaders. There's no way, there's no way to program per pixel what happens. It follows a set formula. But these formulas are quite flexible. And the alpha formula is customized by this register. So A minus B times C, right shift 7 plus D, right? A, you can decide if A in this formula is either the RGB of the source or the RGB of the frame buffer. You can decide if B is the RGB of the source or the RGB of the frame buffer. Interestingly, if you set these to the same thing, you will always get 0, right? Or if you set them both to 0, you can always get 0. So you can make the result of this calculation always be D. So for example, if you want to say ignore alpha, you would just say A equals 0, B equals 0, C equals anything, right? It doesn't matter, it's a multiplier. And then D equals either the value of the source or the value of the frame buffer, right? Either draw everything or draw nothing. Cool. So maybe that's the default, right? Maybe the default is to say 0 everything, in which case you will just draw nothing. So the only thing I'm kind of concerned about here, I guess, is the fix register. Fix is used as alpha. Okay. Input alpha value. So C is meant to be the alpha, right? We're meant to multiply this number by whatever's in C. This means that this means that, what does this mean? This means that we can fix the alpha at a certain level, right? So we could even try and do this. We could try and say draw absolutely everything with an alpha of essentially 0.5, right? And here it kind of explains. The range is 0 to 255, 128 is 1.0. So there's kind of like super alpha. There's like super opaque rendering. But we'll get to that. All we need to do for now is write 5 things to a buffer, right? So we've got an A. A in this case is going to be, so we just want to draw the source multiplied by the alpha. So source is going to be RGB of the source. A is going to be 0. B is going to be, A is going to be 0, which is the source color. B, we don't want to subtract anything from A. We just want A, right? We just want A. Do we? Do we just want A? Ooh, hold on. Let's, that's hard. A minus B times C. Do we subtract the color and then multiply that by the... Is that how alpha works? Let's see if alpha blending. Hell yeah. Okay, this looks like the stuff we want to see. Except they're not in full. Alpha blending tutorial. I love it. View algorithms. Okay. So source A times source B plus alpha times D. So this is very, very different, right? This is very different to the kind of equation we're looking at for the PlayStation 2. Kind of. Source alpha. Oh, no it isn't. This is just expanded, right? So this is saying, where 9. This is saying, so A times B plus 1 minus A times D. This is the same as saying, right? So alpha. Okay. Let's go. Let's do some math. So A, oh my god, my handwriting. A minus B times C, let's call it C prime because it's C right shift 7, but that's really just C, like it's some constant, plus D. This is the same as AC minus BC plus D, right? So this, oh, I'm having trouble with my things today. This is like this without the 1 minus A. That's kind of weird. Expand, pull out SA. SA times the lack of... This is a very different formula. It's a very different formula, right? What this is saying is, let's go S, let's go A, let's go A, hold on, B, A and B. That's not what I'm doing here. This isn't the actual alpha channel, right? This is working. This is working. I don't know what this is working on really, right? Like what are A and B? Are A and B like vectors of color? I guess they are, and you multiply the vector. So what this is actually saying is alpha. So this is C, right? S of A here, or A of S here, is C in our equation. So this is like saying C times, okay, we can do this. C A, the name A here being confusing, but that's okay. C times A plus 255 times B 255. The constant here is super annoying. 1 minus A. There's no 1 minus A here. Okay, let's just experiment. I'm biting off more than I can chew here. We've got more than what we need to just start playing around with values. So let's do the dumb thing first. Let's say A is 0. A is the RGB source. B is going to be 10. We're not going to subtract anything from it. Okay, so 2. C is going to be the alpha source, 0. And D is going to be 0. We're not going to add a constant to it. Cool. And the fix can just be 0. It doesn't matter. And then we have to come up and we have to say, hey, we're putting an extra thing in this gift tag. There are now 6 things instead of 5. Okay, so now we just need to define gift tag AD alpha. And we can do that. This is beautiful. This is clicking. This is making sense. So buffer, that's the wrong desktop, let's go buffer.h. This is where we define all of our wonderful functions for working with buffers. This returns an int because maybe I'll want to return status codes in the future, maybe not, we'll find out. Struct d2d state s int a int b int c int d and int fix. I guess we'll take an int for this, why not? And then we go to buffer.c, draw buffer.c, perfect. So these functions are all just pushing data into a buffer, right? There's nothing particularly complicated about them. They just rely on a lot of domain-specific knowledge about the PlayStation 2. So let's go gif AD. We're setting the register alpha 1. Should be alpha. Oh no, alpha maybe underscore 1. Need to double check that. Let's pull up. That's the wrong window. PS2 SDK. We're going to quickly search the PS2 SDK source for reg alpha. Okay, alpha and alpha 1 are defined as the same thing. The PlayStation 2 has 2 rendering contexts, and you can swap between whether you're using like any alpha underscore 1 or alpha underscore 2 or text O underscore 1 and text O underscore 2 for which text you're drawing. It's a very flexible system. It's very cool. We completely ignore it for now because it's complicated. So reg alpha, and then we're gonna do some bit shifts. So shift. We shift A, we mask it it is 2 bits and we don't shift it at all. That's good news. That one's easy. Shift B, we mask it. We shift it 2 bits over to the left. We shift this 4 bits over. We shift this. Okay, 2. Shift C, we mask it to be 2 bits in size, and we shift it over 4 bits. Shift D, mask it to be 2 bits, shift it over 6, and then last but not least, shift fix. We can actually ignore fix, but let's not. We shift it over 32 bits, which is good, and we mask it to be 8 bits in size. So mask it to be 8. So 1, 1, 1. Mask it to be 8 bits in size, and then we shift it over by 32, and that's it. That is how you build. That's how you populate one of these registers. So we push it into our buffer, it becomes part of our draw command. We can now set this register. So let's build it, and it's going to yell at us because we have done something on line 140. We have put a comma in here, which is a big mistake. We build it, it looks okay, we run it, and nothing looks different, but we'll think about that. MU Stephen Play says, PS3 game dev for when? That is a loaded question. That is a loaded question. PlayStation 3s are even more complicated somehow. And, oh boy. I'll master PlayStation 2 dev first, and I'll move on to it. The winky face. I love it. I love a good cheeky comment. Thank you for stopping by, and thank you for showing a bit of passion for Sony. I love to see it. You love to see it. Okay, so we're drawing a sprite. This is the header for the GPU commands where we draw the sprite. We are now setting 6 registers instead of 5. This has gone through correctly. This has populated the correct section of bits in the buffer. Okay, the first thing we do is set an ST coordinate for the texture. That's fine. Then we set a color. Then we set a position. Texture coordinate, color, position. Hold on. 6. I don't know. No, sorry, that's the texture data. Before this. I'm looking at the wrong thing. Here, we set the AD register, which is basically just a fancy way of setting data in GPU registers directly. We send 1 loop of this, but we set 6 registers in... we send 6 loops of 1 register. Yes, that's what we want to see. Okay, so we do this, we do this, we do this, we do this. This is the new thing we're setting. So 1, 2, 3, 4, 5, 6. Because we set the prim register last for a whole host of interesting reasons. Okay, we set this to 10000 1000 1000 1000 1000 1000. So what does that map to in here? 10 for D, that's 0. 00 for C, that's source. 10 for B, that's 0. 00 for source, that's for A, that's source. That looks good. That looks like what we expect. So now let's experiment with this value. Let's go into it and let's say what happens if we go back to draw 2D and let's set this as 0, right? Let's subtract the background color from the foreground color, okay? So we build, we run, what happens? We get something different. Now that is an interesting experiment. Why do we see this? Why do we see black when we draw this? I don't know. I actually am at a loss for words here. That was not... Okay, so what did we do, right? We're plugging numbers into this formula. We're saying take the source color, what we are... Okay, hold on. Let's take a deep breath. We're saying 0. A is 0. Take the source color. And then B is 0. Take the source color. Subtract the source color from the source color. This is 0. What 0 times anything is 0, and D is unsurprisingly 0. So we're saying set the color to 0. 0, 0, 0, right? RGB, that is pure black. And that's why we're getting black rectangles. So the good news is we did that correctly, right? This is actually having an effect. Now, what I actually wanted to set this to, sorry, while I just get lost trying to find the right workspace, what I wanted to set B here to was 1. And this is when I think we'll start to get interesting values. Let's go 1, let's run it. And let's actually compile it and then run it. Then you start to see some differences. And we still don't see anything different. I think what I need to do Okay, I think what I really need to do is go into texture. Let's come in here and let's set the color to 0. If alpha is 0, right, we should be multiplying all of this by 0. See, we set this to the alpha of the source. So it's the alpha of the source. So let's see if we can draw this and just draw nothing, right? We expect to see nothing, and we don't. Okay, there's something we need to check here, right? Because something is clearly wrong. This formula is getting run, but the alpha multiplicand seems to not do the right thing. It seems to not take effect. So we're going to go down, we're going to check out the primitive register, because we've looked at this before, primitive drawing settings, okay? Because I believe, let's see, type of primitive, shading method, texture mapping, fogging, alpha blending. Do we have alpha blending on? Do we set Abe? Bit 6 in this thing. I think we do. Let's double check. Draw2D.c. I believe buffer.c ad prim. Yes. So we always set alpha. Alpha's always on. And we can see that in my game, right? I'm doing semi-transparent rendering. That's good. What isn't good is this then not behaving the way I expect it to. Okay. There is blending control units. Alpha blending alpha pixels. That should be okay, right? Alpha correction value. I don't know what this is. Let's just try playing with some more different values here. So let's try saying RGB value. Let's try saying the alpha value from the frame buffer is used. Let's see what happens, right? Let's just try some stuff at this point. Draw 2D. Let's say state prim sprite. Where are we? Alpha. So B. Let's say B. Let's say C equals 0x1. What do we get? Still no change. Really, you know, we would expect to see something here, surely. Let's do something else. Let's do something else crazy, right? Let's set the fix to say 0x10, and let's say that we want C to be set to whatever we fix the alpha to here, right? So we're saying hard code an alpha value. Let's also do this in hex, because it's just a little bit nicer. So A, B, C, we'll go 0x2, 2. We build it, we run it, and we're back to, ooh, this is interesting. Have a look. So, we're drawing this less transparent, but we're not blending it against the background, right? We're not, so, this is interesting, right? Because we're subtracting the background from the foreground. What if we go back to not subtracting anything? Okay, we're just drawing the base color, but less of it. And that's the same thing, right? It's very, very similar. The background color or not at this low level of opacity shouldn't matter. So let's go back to hopefully using the alpha value we provide. And that's it. Hold on, I didn't rebuild. I'm a idiot. I didn't rebuild. Okay. And it goes back to being very bright. That's very odd. Sprite. Set color. Sprite. That's weird that it doesn't seem to respect this value, right? Oh. Okay, hold on. My brain's doing something, right? My brain's doing something. There's more than one alpha at play here, okay? We're drawing an image that is fully opaque. All of the pixels have the maximum alpha value. I thought that if I set the color to alpha, that alpha would be interpolated across the whole sprite. But maybe not. Maybe alpha's special. Maybe alpha's special. How can I check this? So what if I set the color to something else? What if I say draw this really, really red? Does that red get interpolated? Maybe. Hold on. Red's the wrong color. Let's say everything but red, right? What does this look like? It doesn't look like there's any change. So it looks like this color actually is not being interpolated across this texture, right? I think that's a reasonable assumption to come to. Thank you very much, SBTW15, for the follow, by the way. Almost missed that one. Welcome to the Madhouse, where we love big buffers with lots of data. I think there's a song about that. Okay, so color appears to not be interpolated. We can also, like, really, really check this if we set everything to 0. Color is not being interpolated over primitives when we're drawing textures. This is important. This is very, very important. So if we set the color to 0, this should be getting blended with the texture somehow, right? What does this color value mean? Because if we draw, for example, if we draw... Hold on, we gotta go back into the really primitive docs about what the pixel pipeline process looks like. That's very hard to say. Don't try and say that 3 times quickly. You might hurt yourself. Okay, so let's have a look here. GS features, drawing. Let's start at the drawing process, right? Because shading and texture mapping, I feel like there's some interconnection between these two things that is going to be right on the money for what I need to change, right? Where shading and texture mapping overlap with alpha blending. Okay, there's got to be something. Local memory, this is great. Bandwidth of frame buffer. By the way, texture bandwidth, okay? 9.6 gigabytes per second. 9.6 gigabytes a second of texture transfers within the PlayStation 2's memory. Insane, right? That's ridiculously high. Completely makes up for the 4 megabytes total VRAM, including frame buffer. Okay, so interestingly, when you look at these performance benchmarks, alpha does not matter. So that tells me turn alpha on always, right? Alpha is on. It doesn't matter. Fogging and anti-aliasing do impact, quite a bit, in fact. If you go from flat shading to Gouraud shading, you basically incur a 2 times slowdown. So that's a big deal. Okay, local memory, we don't care about this. Addressing, we don't care about this. Storage format, we don't care about this. We maybe care about this a little. We shouldn't care about this. Drawing function. So we looked at this last stream, and it's complicated. Okay, it's very complicated. Where does A go? RGBA. So this is a register that we set that has the color. It goes into the texture mapping function. The A comes out separately and goes through the anti-aliasing pipeline, then comes into the pixel test. Okay, so the texture, it gets combined with data from the CLUT and comes in here, and we also pass an alpha in here. So there's an alpha here, and there's an alpha here, and texture mapping does something to it. What does texture mapping do to these 2 alphas? How do they get combined? Where do we tell... Oh... Okay, my brain's doing something else. We're going to keep reading here, but my brain's going to do something else. Where do we tell the texture mapping unit what to do with those 2 alphas? I suspect it's in one of the text registers, right? Text 0, text 1, or text 2. There are 3 registers that control texture drawing. Text 2 is a subset of some of the others. It's complicated. There's a whole host of reasons why that is. I've forgotten some of them. Anyway. Rasterizing we don't care about. Texture mapping. Textures are mapped to pixels. The pixel color is determined by applying the texture function to the texture RGBA value read from the memory block and the RGBA value calculated by the DDA. Okay, so the DDA calculates, it rasterizes the color for a triangle, which is then combined with the texture mapping RGBA value. That's important. Anti-aliasing, whatever. Blending is done according to this. That's good. So texture mapping is the key, right? Texture mapping is the key. Let's come down. Let's see, where is texture mapping described? Texture mapping. Assuming TME equals 1, that's true for us. Texture data must be stored in the texture buffer. Blah, blah, blah. Yep, cool. Images created via the drawing process can be used as textures. This is a whole rabbit hole of things I want to do, but will struggle to do. Texture mapping process flow. Okay, so the DDA generates our stuff for each pixel, right? And for each pixel, this stuff flows through. We kind of care about ST here, I guess, because it goes through and blah, 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 goes through accesses texture, blah, 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 blah. Fragment color, texel color, texture function. Okay, here we go. This is it, right? This is what does the combination, the texture function, and we played around with this recently. Color component, don't know what that is. Fragment color, texel color. These are the two bits we're trying to combine right now. The fragment color is what we're setting. The fragment color is what we're setting here. The texel color is what is actually read from the texture data. So the texel alpha is always fully opaque. The fragment color in this case should be almost entirely transparent. How do these get combined? Modulate, decal, or highlight. Where are these described? Texture function. The TFX field. The TFX field represents the operation mode of the texture function. Cool. That doesn't actually tell me anything. Format conversion, RGB expansion, clock buffer control, temporary buffer, blah, 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 blah. Texel sampling. I mean, like, seriously, if you want to nerd out about signal processing, this stuff is incredible. Texel function, here we go. So what are we setting it to? Let's go in to buffer.c and look at, where is this set? Tex. TFX, yeah. So when we set tex O, the last argument is the texture function, how this is computed. So let's go to draw 2D. We're in our sprite. We set tex O. The last thing we set, the last argument is 1. So the texture function is 1 O. I don't know how these map to these things. Okay, we've got to look at two things here. So there's modulate, there's decal, there's highlight, and there's highlight 2. So what's the alpha value thing? Alpha value equals alpha F. So the textures are blended with the colors. So these are the things that come from the DDA, and these are the things, the colors T of the fragment. No, so these are the texture colors, and these are the fragment colors, yes. And they're converted to output colors. So if we look at modulate, the output is always the alpha from the fragment. TCC equals, TCC. Okay, here we go. TCC equals RGBA. Haha, yes. Yes. When the... Okay. So maybe we do this. A outputs a texture color as is. AT. Yes. I believe we're in decal mode. We have this set to RGBA. I believe we're in decal mode. Right, so the texture color according to the fragment color. So we want modulate. Modulate is multiply the stuff together, combine them. Adds pure white based on the alpha value. We don't want that. Highlighting opaque. Yeah, okay, so we want modulate. I think we've changed it to decal. Let's find where these values are actually used. Modulate. Blah, blah, blah. Modulate. So I believe we've just set it to decal. We want it to be 0. Which one's TCC? TCC is the penultimate. It's set to 1, which is decal, which ignores the alpha. Let's set this back to modulate. Get some funny looking textures, but we'll deal with that later. And we're ready to go. Beautiful. This is now transparent, but not in the way that I'd hoped. Again, we're drawing something that is not blending with the background. We're drawing it less, but we're drawing it less over nothing. So let's go back in. We are, hold on, let's go to alpha 1. B, we want B to be the RGB of the frame buffer, I believe. We have it set to nothing, so we're just multiplying this. We're multiplying the source color by the alpha, which, as you would expect, just draws less of the source color, right? So let's subtract the frame buffer. We'll build it, we'll run it, and let's hope something different happens. Something different does happen, but not quite as I'd hoped. Now, I'm having another thought, okay? So we start with, oh, this is like some real brain stuff. Okay. We start with a background color. We take a foreground color, we subtract the background color, and then we multiply that by a transparency. But then when we draw that, it's just very dark. So what if we add the background color back in? Is that what we have to do? Is that how we achieve this? I think it is. I think it is. So let's add the background color back in. We're going to build, we're going to run, and this is going to look beautiful now. And that's it. We have ghost rendering. Okay, so alpha is in. Alpha is basically free. This is beautiful. I love it. This is everything I've wanted from this stream already. We can take this. We can use it. I love it. I love it. This is so exciting. Let's copy this over. Let's go to text, try. Let's go in. We're gonna set this to 0. We're gonna set this. No, we're gonna leave that as 1. No, hold on. I did that backwards. We're gonna set this as 0 and this is 1. No, that's not right. What? The thing should be not that thing. The thing should be modulate. They should both be. This should be 1. This should be 0. This should be 1. This should be 0. Right? Yeah. Nice. And now we get now we get this. Now we get this. So we don't even have to set the alpha register. That was unnecessary. That was an unnecessary step. So let's go back to where we said alpha. We'll get rid of it. We'll go back. We'll say, hey, we've only got 5 gift tags now. We're going to build and run this again, and it's going to be delightful. Love it. Bloody love it. So let's go to our draw example, our texture example, and let's change. Well, first off, let's draw this. Yeah, let's go back to drawing the actual texture color. And now we see some of the detail. That's good. That's perfect. And in between these, let's go D2D, set color. Let's go 0. Let's go hard on the green and hard on the blue, but still keep it semi-transparent. No need to build there. And you can see. You can. Oh, hold on. So setting the color higher than 8.0 is a little bit dodgy, right? 8.0 is white. Anything higher is probably not okay. And we have no red, so we don't actually get like any color there. What if we do this? Yeah, cool. I'm happy with that, right? The red looks more red here. Like much more red. So this works. This works. Let's head over to Draw 2D Lure and see if we can do this as well. We should be able to change over to our slow renderer, and we should see no difference in behavior. Let's go to texture. Let's go to sprite even. Let's go to where we set text O. Or is it set text? And this actually seems to be set correctly. I think we need to do a 1 here. But let's go back to our texture example. Let's go PS2 prog slow 2D is true. We're going to swap over to our Lua renderer. We're going to run. And this should be not quite the same. We appear to not be setting this correctly. Oh, Ultimate Sacrifice stopping in. How's it going, man? And Dbut2 with a follow. Thank you so much. How are you going, Ultimate Sacrifice? It's been a long time since we've spoken. You've got a tick. How long have you been ticked for? When did this happen? Insanity. I went to Fortress in Melbourne last night, the little gamer bar place, esports event venue. It was cool. It was pretty nice. I think, you know, it's no secret that I find certain it was a little bit tacky, okay? But I liked it. It was a good vibe. I met some cool people, you know. It was like a Melbourne game creative meetup. I sold a lot of people on my stream. I can see a few people have followed recently who were from that event, which is really awesome. I met a bunch of uni students. Felt very old. But yeah, Ultimate Sacrifice streams, like F1 driving stuff. He was a very good teammate in Quake Champions way back in 2018. 4 years ago, right? 4 years since BAM 2018. Crazy. Since we played that amazing overtime game on Awoken, which I'll never forget. Let's see if I can dive into the implementation of this, right? So bufferlua.c. We have this really janky set text function, and this to do. So this is the kind of thing I need to clean up, right? Where we're calculating, we're doing this stuff TFA. See, we're doing all of this shifting differently, and this makes me really nervous. We're doing it differently because we kind of have to, but this just makes me really, really nervous. So base, blah, 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 push integer, yes, yes. Quake Champions is 5 years old now. I saw the Spud Hunter say that. It blew my mind. It's kind of crazy, right? I was telling stories to people last night about, doing Quake stuff, and I was like, oh yeah, and because there was a streamer at Fortress last night, like a fairly popular one, and some of the people went and got a photo with them. And I was saying about when we were at GG Easy at the Melbourne Esports Open in 2018, and Vondel walked in, and they were like, who's Vondel? And I'm like, I don't even think he streams anymore, right? Like, it's been a couple of years since all that stuff happened. It's like a whole different world, right? The world has moved on. I'm out of touch. I'm an old man yelling at a cloud. It's crazy. It's crazy. So I could turn this logging back on to see what we're actually writing out, and that might be a good idea because I suspect we're not writing the correct thing to these fields. But let's make it a trace log now. We actually have the capacity to do this 100% of the time now. So let's build it. Let's run it. I think I still have trace logging on. I do. That's great. We are writing Texo. Here we go. These are the big boys. Oh, Vondel works at Twitch now. Holy crap. Yeah, I don't actually watch much Twitch these days, right? Since I started streaming, I basically stopped watching. I have a finite amount of Twitch in my life, and either I am streaming or I am broadcast, or I'm watching, right? I can't do both. Do I watch QPL? Nah, I'm not really watching much Quake stuff. I'm not really thinking about FPS that much. I'm probably going to come back and play AQL Season 3, though. Do some stuff. I may even stream some games if people are keen to watch me play first-person shooters. Texo. So, Texo. Okay. Let's find this. Texo. God, this register's a mess, right? For people who haven't seen me work with this register before, the reason that this is a special case in Lua is because this field overruns the 32-bit word boundary, right? Bit 30 to bit 33. It's disgusting to work with because I'm pushing integers in 32-bit increments. It just gets gross. Yeah, Ultimate Sacrifice, get in touch. Let's go somewhere, have a drink, catch up. That would be amazing. I would love to hear what you've been up to and how you've been going. And then, yeah, I'm going to focus in on this and see if I can work out. But, I'm kind of looking for a distraction because this is the grossest part. Every time I have to look at this register and this data format, it just kind of breaks my soul. So, bit 34 and bit 35 and 36. So we've got to write this out. We've got to think about this, okay? Bit 34. Bit 34. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24, 30, 32, right? So 8 nibbles, 2 bytes. No, wait, that's 2 bytes. That's, hold on, 1, 2, 3, 4. Oh, wait, no, yeah. 1 byte, 2 byte, 3 byte, yeah. In bytes, 32-bit word, right? So this is bit 34 and 35. So we need a second. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So none of this. This is just padding. But then it's going to be 34. So each of these zeros is like 4 bits of zeros, right? Each of these zeros is a nibble, 4 bits. So we're going to go... So this is bit 0, 4, 8, 16... 20, 24, 28, no, 20, wait, 0, 4, 8, 12, 16, 20, 24, 28. Counting's hard. 32, 33, 34. So 0, 0, x, y, y, 0, 0, 0. Okay? These are the bits that we are setting, where X is TCC and YY is TFX. This is how we're breaking this data format down. So TFX should be 0. That's what we want to see. And TCC should be 1. TCC should be 1. Having alpha on literally has no impact on our performance, our triangles per second. I don't see any case where I would ever have this set to 0. Unless maybe I was clearing the screen. But anyway, neither here nor there. Not important right now, Tom. This should be 1. TCC 1, TFX 0. So we expect to see 0, 0, 0, 0, 0, 1, 0, 0. This is 0, 4. But there are other fields around it. So TH and TW are going to be set. So I guess these are the important... Let's go 1. This is the important bit. And then these have to also be zeros. So when I look at the buffer, what do we get? When I look at the buffer, what do we get? Let's actually do this text O, register 06. Let's go 06. We're doing this for sprite, right? Where are we doing this? We're doing this for sprite, yes. Okay. Okay, we got this, we got this. So when we draw a sprite, which is up here, when we set text 0, which is the register up here, this is what we set it to. So the lower 8 bits we can ignore. The lower 32 bits we can ignore. 1, 2, 3, 4, 5. So 1, 2, 3, 4. And then this. So this is good. This is easy, right? Because we were saying like 0, 4. What we're seeing is 0, 5, which is just in terms of bits, 0, 0, 0, 0, 0, 1, 0, 1. So this bit's set, but we don't care about this bit. This is being set correctly. So then why don't we get transparency? I guess the other thing to consider is that maybe when we set the prim register, we don't have it enabled. So let's look at gif.lure. Okay, and when we set prim AD, yeah, so we don't set, oh god, I forgot I did it like this. Oh, this is a nightmare. When we set the AD register, when we set the primitive register, sorry. Oh no, I ended up in a bad place there. When we set the prim register, hold on, I just gotta jump to definition. Getting at RSI navigating this frickin' 100-page document. Prim. Okay. ABE, alpha blending enabled. I believe that's what it stands for. Or maybe I'm making that up. 6 bits. Okay? 6 bits. So, shift it 6 bits. Multiply it by 2 to the power of 6. Yeah? No, if you multiply... So to get here, you multiply 2, 4... No, 2, 4, 8, 16, 32, 64. So, bits equals bits, or 64, right? We just or this number, this magical constant in. We set a field in the primitive register, which sets up the GPU to draw things with alpha blending. If I just run this now, it should work and have alpha. And it does. Oh, doesn't that feel good? Doesn't that feel bloody excellent? Don't you love it when you set up an expectation and then your code just smashes that expectation out of the park? Incredible. God, I'm doing some good work lately. Let's commit this bad boy. Let's check out a branch first. Holy crap, I haven't even checked out a branch yet. I completely fell down that rabbit hole. So this is issue 58. Let's call it GH58. Let's call it... Am I going to call it feature? Let's just not. Let's call it GH58. Transparent textures. Git commit. Let's just do it all in one. Oh, actually no. Let's do my favorite new thing. Git commit p. Okay, so do we want this to be part of the commit? Yes we do. Let's push in. No, we don't want this to be part of the commit. Don't want this to be part of the commit. We want that to be part of the commit. Let's push in all of the Lua stuff first. Cool. Implement. Let's tag the commit. Implement texture transparency in Lua. Cool. Now let's go through git commit. Still no to this. Still no to this. Let's add... Oh, we don't actually need to set alpha anymore, hey. Let's add it anyway, I guess. But this is the important thing. A bit of a janky commit now, I guess. Oh well, we'll survive. Draw transparent textures in C. Let's not commit this. Let's commit this, screw it. And then no to that, but yes to this. Oh, I forgot to tag those anyway. And then the only thing we have left is this, but this is just for our local testing. We never actually want to commit this to our code base. And then we need GH58. Is there a way I can just like get the current branch name in this? I'm always typing out the current branch name like an absolute scrub, and it's never fun. Thank you. Oh no. I checked out a branch. I didn't do... Oh, fuck. Oh no. Okay, hold on. We're gonna fix this. We're gonna revert a commit on I pushed to main. Okay, first things first. Let's go settings. We can make this a protected branch, right? We can go protection rules. Require status check. Require require deployments. Deletions. How can I just make this not an okay branch to ever push to? How can I just stop that happening? Sign commits. Oh, whatever. Screw it. It's too late. I am going to revert that though. 9A-FOF-C9. Include administrator on branch rule. Thank you very much, debut2. Rewrite the history before anyone notices. Exactly. I'm not going to rewrite history. I'm going to revert, and I'm going to push the revert, and then I'm going to merge the changes into a PR. No, I guess actually, if I do a hard checkout of if I could just hard check out this, right? I actually have to revert a bunch of... Yeah, okay. I'm sold. Let's check out this commit. Let's git reset hard commit. Yeah. Okay. GH85. Git diff main. We've got our nice thing here. Oh yeah, of course. I should have realized it would have prompted me before I authenticated because my local Git doesn't know which upstream branch it's tracking. Anyway, 58 transparent textures, and then let's check out. Then let's check out main. Git checkout main. Push F. Right? Just force push to main. This is fine. Ah, fuck. Protected branch hook declined. Fuck. Oh no. So do I just This is literally the stuff I was just talking about. Protection rules. I mean, I guess I could just like require status checks up to date. That's fine. Include restriction for administrators. Cool. Allow force pushes. Let's just temporarily allow myself to force push and rewrite history. This is terrifying, by the way. I mean, it really isn't. Like, I've just reverted a few commits. We're all good. We're all good. And no one needs to know. Allow force push, no. And require include administrators in these rules. Thank you very much, debut2, for that helpful pointer. We have fixed master. We've done it. We've solved it. And look, now I can just make a nice pull request. And look at these nice changes, right? Look at this nice change set. Ultimate Sacrifice, have a good night. Thank you so much for stopping by. Always great to see some Quake people coming by and supporting the show, because it's a little bit different, right? But yeah, all the best with your streaming. It's looking really awesome. And yeah, hopefully we'll catch up in person soon. That would be amazing. It's been so long since I've seen some of these like Quake people. Let's just do a quick make lint and make sure this is all okay. Looks good. Make format. See if anything changes. I'm not checked out to my branch though, so let's make lint. Let's do this again. So yeah, make format. How we looking? Make lint. It can never clean up this stuff. Draw buffer. Source draw buffer.c line 135. There is a trailing space, but we're good. We are very, very happy. Git. And now we're no longer pushing to master, which is great. Number 58, transparent textures. Correct. We're setting the texture function correctly to enable rendering transparent textures. Sure, that sounds good. Assign myself to this pull request. Was this a bug? I guess this was a bug, and it's graphics. Projects, this engine, milestone, 2D sprite-based renderer. We're going to create a PR, and we're going to merge it. We're going to merge our own PR. This is good fun. This is my favorite part of the day. Merge my own code in. Okay, so we're setting this thing correctly. 1.0, that's great. An example, which is good. We're setting transparent textures to always be on in Draw 2D, which is great. We're doing some better trace logging, which is fantastic. We set this probably shouldn't be in this PR, but it's too late. It's here. It's in. And we're missing this when we do... Well, I don't know if we are missing it, actually. Let's check out script... Draw 2D. Because in Sprite, we had to change this, right? We had to change how we're setting text O, 1.0. But I think if I look at text try, I must have known that this was wrong, right? But, oh no. So, text try. Let's just do this as well, just for good measure. We'll make run, just see how this looks. Looks pretty good. Looks pretty good. Oh, except we're not using the 2D renderer anymore. I checked that out. So let's go ps2 prog.slow2d as true. Make run. And that still looks beautiful. Love it. We're doing beautifully. Okay, so what are we doing? We're going draw 2D. Draw 2D. Commit what's our message? Enable or use correct TCC for Lua text try. Let's just go like very simple. Love it. Love it. Okay. We refresh this file. I'm glad I went through the review process and actually thought about my own code. We now set this in 2 places. We see down here, we also set this in 2 places. And let's... Oh, I can't review my own code. Let's just leave a comment though, right? Just so everyone knows I actually had a look. It's good to leave a good, insightful message before you merge something, okay? Even if it's on your own PR. Cool. And this is going to build. I should wait for this to build. I probably should. And then naming pass. I don't think we're going to have time for a good naming pass today, right? I don't think we're going to get around to it. Beautiful, built, merged, and we're in. Yet another feature, well, yet another fix, I guess, smashed out the park. If we have a look at our issues, okay, let's have a look at our projects. Let's have a look at the board, right? I'm calling this engine, by the way. I've come up with a name. I think I'm going to call it P2 Garage. It's not particularly PS2-y, but it's, you know, it's evocative. It's playful. There's no one else using it, so I think this is a good start. I've also just noticed that I'm wearing a stripy shirt, which probably looks horrible on camera, so sorry to anyone who's had to endure this. Example, transparent textures broken. Done. Shipped. Example games we're working on. We're gonna move scripts. So I think I've talked about this a little bit before, right? But if you go to, for example, our texture example, you require draw 2D. What I actually want is draw D. I want you to have to require like p2g.draw2d, have everything namespaced behind some p2 garage namespace, maybe even like fully verbose, right? p2 garage, right? Maybe. I don't know. But I want these things to be namespaced, and I want to move them out of the script folder. I want them to be in script P2 Garage for a whole host of boring technical reasons, but basically I just want to namespace them. So if you make a script called GIF for some reason because you want to load GIF images in Lua or display a, you know, like render a GIF, an animated image, I don't want that to nuke what I have defined, right? Because at the moment, script GIF is stuff for the graphics interchange of the PlayStation 2, which is called the GIF, the GIF, or the GIF, depending on who you ask. So that's going to be very important, right? But I also need to go through and name a bunch of stuff, document a bunch of stuff. There is a lot to do. There's a lot to do here, but this is the top priority. Okay, this continues to be the top priority. This continues to be the single biggest time waster in my streams. Why does Lua crash when I try and use set jump and long jump? This has been an awesome stream, but I think I'm going to have to cut it there. It's getting kind of late. Like I said, I went out for drinks with some people after work, had a good time, and I was out doing stuff last night as well. I've hardly been home in the last 48 hours between work and just socializing. I've got some housework to do. I've got some stuff to attend to. I've got to get to bed because I'm working tomorrow. Got some big stuff to smash out of the gate tomorrow, which is very exciting. So this has been a wonderful stream. Thank you very much, everyone who's tuning in. If you're watching this later on YouTube, be sure to like and subscribe and all that good stuff. I'm going to try and be better at uploading these streams to YouTube quicker, but no promises because life is complicated. Thank you very much, and I'll catch you next time.